Okay, Assalamu alaikum. In this slide, we discuss the rules of differentiation. Okay, this is powers of x rule. Okay, so suppose the function of x is equal to x raised to n, where n is a real number. Then how to find out the derivative of this function? It will be nx to the power n minus 1. So now these are the some examples where we see how we can find out the derivative of the function using the powers of the x rule. Okay, first for this function, okay, where y is equal to x to the power 14. So then dy by dx, it will be equal to, you have to write down the power, okay, here n equal to 14, okay, 14 first, then x to the power, okay, n minus 1. So 14 minus 1. So it will be 14 x to the power 13. Then the powers of x rule applies for all real number. For example, here for the second example, the function of x is equal to x to the power minus 2. So how we can find out the derivative of that function? Here n is negative 2. So we have to bring the negative 2 in front first, okay, minus 2. Then x to the power minus 2 minus 1. So it will be minus 2 x to the power minus 3. Or we can write down minus 2 divided by x to the power 3, because x to the power minus 3 we can write down this way. And then the third example, y is equal to x. So here you have to understand that x, it has power 1. So you have to how to find out the derivative. In that case, you have to bring the power in front 1, then write down x to the power 1 minus 1. So then we get x to the power 0, and you know that if any variable it has power 0, it is actually 1. Okay, and then the powers of x rule also applies to this one, where we can write down the derivative of this function. It will be equal to 1 by 3, then x to the power 1 by 3 minus 1, and we get 1 by 3 x to the power minus 2 by 3, and at last we can write this way. Okay, next, see the next rule. Okay, this is constant function rule. Here you see that the function, it is a constant number. For example, function of x equal to c, where c is a constant. Then the derivative of that function will be equal to 0. For example, find the derivative of the function where y is equal to 4. So since 4 is a constant number, so that means the derivative of that function will be equal to 0. And recall that the function defined by y equal to 4, it is basically a horizontal line. Thus the slope of the line and the derivative of the function is 0. Okay, this is coefficient rule. When any function it is times with a constant number, then we have to follow this coefficient rule. For example, here the function ux, it is times with this constant number c. And remember that this ux should be differentiable. Okay, now how to find out the derivative of that function? It will be like constant c times the derivative of that function. Okay, that means there will not be any change in the constant number. It will be the same. Then you have to multiply with the derivative of the function. So there are some examples. For example, the first one is function of x is equal to 4x to the power 5. So here 4 is the constant number, and this is the function. So how to find out the derivative of that function? It will be equal to 4 times the derivative of x to the power 5. Here you have to follow the power rule. So you have to bring the 5 in front, then x to the power 5 minus 1, which is 4. So then 4 times 5 is 20, then x to the power 4. Similarly, in this case, okay, dt is equal to half t square. So half is the constant number, okay, and t square is the function. So how to find out the derivative? It will be equal to half, then times the derivative of t square, which is 2t. So then after you can cut this 2 and 2, and you will get the t. Lastly, the function is p equal to 5 divided by root q. So here 5 is the constant number, and 5 by root q, you can write down 5 then times q to the power minus half, because we can write down 1 by root q. It is actually, we can write down q to the power minus half. Then you follow the coefficient rule, which is 5 times the derivative of q to the power minus half. So minus half is the n here, so you have to bring the power in front, like minus half, then q to the power minus half minus 1, which is minus 3 by 2. So at last we can write down minus 5 by 2 to the power q to the power 3. Okay, suppose two functions, for example ux and vx, they are added or subtracted as terms of the function of x. Then the derivative of this function will be term by term. Okay, for example, if I want to find out the derivative of this function, it will be u prime x then plus the v prime x. Similarly, if I want to find out this derivative of this function, it will be u prime x minus v prime x. So these are the some examples. For example, here y is equal to 3x plus 5. So now if I want to find out the derivative of that function, I have to find out the derivative of 3x first, which is 3 times 1, because the derivative of x is 1, plus the derivative of 5 is 0. So then that means the derivative of that function will be 3. Then b, here also I have to find out the derivative of this one, this one, this one, and this one separately. So the derivative of that function is equal to, okay, first 4x to the power 3, it will be 4, then times with the derivative of x to the power 3, which is 3x square, minus 2 times the derivative of x square is 2x, plus 5 times the derivative of x is 1, and then lastly the derivative of 3 is 0. And after that, okay, you can get 12x square minus 4x plus 5. Similarly, you can find the derivative of this function. So here the number c, which is 1 by 3 q to the power 3 plus 2q square minus 3. So first the derivative of 1 by 3 q to the power 3, which is 1 by 3 times with the derivative of q to the power 3, which is 3q square. Then plus 2 times the derivative of q square, which is 2q. Then minus the derivative of 3 is 0. So at last we get q square plus 4q. Similarly, we can find the derivative of this function. Okay, this is product rule. If function of x is equal to ux times vx, where v and u both are differentiable function of x, then how to find out the derivative of that function? It will be the first function times with the derivative of the second function plus second function times with the derivative of the first function. Okay, now let's see, these are the two examples here. Suppose you have to find out dy by dx if y is equal to 2x to the power 3 plus 3x plus 1 times with x square plus 4. So you have to understand that there are two functions, okay, they are times with each other. So this is, for example, we assume that this is u and this is v. Okay, now let's see the answer here. Suppose this is u, okay, and this is v, then follow the product rule. Dy by dx is equal to, you have to write down the first function first, times with, okay, derivative of this function, second function, which is 2x, plus you have to write down the second function times with the derivative of the first function. So the derivative of this first function, it is 6x square plus 3. And then after you simplify, you will get 10x to the power 4 plus 33x square plus 2x plus 12. Now the next question, find the slope of the tangent to the graph of, that means this is the function 4x to the power 3 plus 5x square minus 6x plus 5 times with x to the power 3 minus 4x square plus 1 at x equal to 1. So first we have to find out the derivative of this function. It will be, follow the product rule. First you have to write down the first function, then times with the derivative of the second function, which is 3x square minus 8x, plus you have to write down the second function, okay, this one, times with the derivative of the first function. The derivative of the first function is 12x square plus 10x minus 6. Then if you substitute x equal to 1 into this first derivative, we find the slope of the curve at x equal to 1. That means f prime 1, that means the derivative of the function at 1 when x equal to 1, then we will get it is 72. That means we could of course avoid using the product rule by multiplying the two factors before taking the derivative. But multiplying the factor first might involve more work than using the product rule. Okay. Now next slide we discuss another rule.
Okay, in this slide I discuss the quotient rule. So suppose if you find that the function, it is a fraction like this, function of x is equal to ux by vx, where u and v are differentiable function of x, and remember that vx is not equal to 0. Then how to find out the derivative of this function? It will be equal to, okay, vx times with u prime x minus ux times with v prime x divided by vx whole square. So now let's do two exercise here. So suppose function of x, it is equal to x square minus 4x divided by x plus 5, and you have to find out the derivative of that function. So since this is a fraction, of course you have to use this quotient rule. So using the quotient rule, we assume that this is ux, x square minus 4x is ux, and x plus 5 it is vx. Then if we follow the quotient rule, the derivative of that function will be equal to, okay, first is vx, so here vx is x plus 5 times with the derivative of ux. The derivative of ux, it is 2x minus 4, then minus ux, okay, x square minus 4x, then times with the derivative of x plus 5 or vx, which is 1, and then divided by vx whole square, that means x plus 5 whole square. After you simplify, you will get x square plus 10x minus 20 divided by x plus 5 whole square. Now the second question, that if the function of x is equal to x to the power 3 minus 3x square plus 2 divided by x square minus 4, you have to find the instantaneous rate of change of the function at x is equal to 3. And when we discussed the differentiation in the our first class, we found that actually instantaneous rate of change is the derivative of that function. So that means here you are asked to find out the derivative of this function. So now since it is a fraction, okay, so we have to follow the quotient rule. So we have to assume that this is ux, okay, and this is vx. Okay, so follow the quotient rule. So first we have to write down vx. So vx here is x square minus 4, then times with u prime x. So this is u, so the derivative of this u, it will be 3x square, okay, minus 6x, then minus, okay, ux is this one, x to the power 3 minus 3x square plus 2 times with vx. So v prime x, so v prime x here 2x, and then divided by x square minus 4 whole square. After you simplify, you will get x to the power 4 minus 12x square plus 20x divided by x square minus 4 whole square. Okay, so now after that you have to find out the value of this derivative or instantaneous rate of change when x equal to 3. So that means you have to now substitute x equal to 3 into this derivative, and after substitute x equal to 3, you will get the value is 1.32. So this is the thing, we will get the derivative of that function, okay, using this quotient rule. And when we get the value 1.32, what does this mean? This means that when x value change, okay, by 1 unit, then the y is changed by 1.32 unit. Okay. Okay, now this is chain rule. If f and g are differentiable function with y is equal to the function of u and u is equal to the function of x, then y is a differentiable function of x. And then if we want to find out dy by dx, it will be equal to f prime u times with g prime x. So that means dy by dx is equal to, we can write down f prime u means dy by du times with g prime x means du by dx. So now suppose this is the function y is equal to root over x square minus 1, and you have to find out dy by dx. So in that case, if we write this function like this way, y is the function of u, that means it is equal to root u. How we can write down root u? Because here we assume that u is equal to x square minus 1. Okay, so in that case we can write down y is equal to root u. Root u means u to the power half. Then we can write this derivative dy by dx is equal to dy by du times du by dx is equal to, okay, so first we see dy by du. So if y is equal to root u or u to the power half, then we can find out the derivative of this function dy by du. It will be half times u to the power minus half, because why? 1 minus half. Okay, u to the power 1 minus half become minus half, then times with, okay, the derivative of this one, u is equal to x square minus 1. So the derivative of this function, okay, du by dx, it is actually 2x, because the derivative of x square is 2x and the derivative of 1 is 0. So then we can write down, okay, here we can cut, okay, these 2 and these 2, it become u to the power minus half times with x. So again we go back to like u to the power minus half, we can write down 1 by root u times with x. So then we can write down x by root u. Now if we want to write down this derivative in terms of x, then we can substitute u is equal to x square minus 1. So then we get dy by dx is equal to x by root over x square minus 1. Okay, this is the power rule. If suppose y is equal to u to the power n, where u is a differentiable function of x, then we can write down the derivative of that function like dy by dx is equal to n, then times with u to the power n minus 1, then times du by dx. That means we have to first find out the derivative of this function, okay, the whole function. It will be n times the function to the power n minus 1, then times with the derivative of u, okay, inside the function. Okay, so now there are two examples here. Suppose y is equal to, okay, x square minus 4x to the power 6, and you have to find out dy by dx. So you see that x square minus 4x, it is the function, and it has the power 6. So in this case we have to follow this power rule. Okay, this has the form like we can write down y is equal to e to the power n, and here n is 6, so we can write down u to the power 6. How we can write down u to the power 6? Here we assume that x square minus 4x is u. So then if you follow the power rule, you can write down dy by dx is equal to, okay, here you first bring the power in front like n, u to the power n minus 1 times the du by dx is equal to, here n is 6, okay, then u to the power, okay, 6 minus 1 times with the derivative of this function. So the derivative of this function is 2x minus 4. Okay, then what we do here, we just substitute u equal to x square minus 4x. So then if you substitute u is equal to x square minus 4x, we will get 6 times x square minus 4x to the power 5, then times with 2x minus 4. After we just make it simple, we will get 12x minus 24 times with x square minus 4x to the power 4. Now let's go to the second example. Here p is equal to 4 by 3q square plus 1. We have to find out dp by dq. So now, okay, we can use the power rule. Okay, then we write down this equation this way, that p is equal to, okay, 4 times, okay, 3q square plus 1 to the power minus 1. Okay, then we find out the derivative dp by dq is equal to, here you see that 4, okay, the constant number, then times with the derivative of this one. Okay, here you follow the power rule, then you have to bring the minus 1 first, then write down the function 3q square plus 1, then to the power, okay, minus 1 minus 1. So minus 1 is minus 2, then times with the derivative of inside this function. Look, it is 3 square plus 1, so the derivative of this part is 6q, because the derivative of 1 is 0. So after you times with 4 with 6, we will get minus 24q, and then divided by, okay, this part we can write down 3q square plus 1 whole square. Okay, so you can see here how we can use the power rule, okay, in order to find the derivative. Okay, now if suppose, okay, the function, it is a logarithm function, okay, suppose in this case we consider the natural log function, and here you see that y is equal to ln fx. So then how to find out this derivative of this logarithm function? It will be dy by dx is equal to, first you have to find out the derivative of this function, okay, it is f prime x, then you have to divide it by this function. Okay, let's see here two example here, and we try to find out the derivative of these two functions. So number one exercise is here, if y is equal to x to the power 3 plus 3 ln x, then you have to find out dy by dx. So now you just follow the the rule, like dy by dx is equal to, here x to the power 3, we have to follow the power rule. So it will be 3, then x to the power 3 minus 2, which is 2, then plus 3 times, okay, so this is the natural log function. So this is actually the function of x, which is x. So you know that the derivative of x is 1, then divided by the function which is x. So you can get 3x square plus 3 by x. So now this is the second example. Okay, here you see that y is equal to x square times, okay, ln x. So now you see that here two function, one is x square, another is ln x. So you have to follow the product rule, right? So okay, let's do. Okay, so the derivative of this function y prime is equal to, follow the product rule first. Can you remember the product rule just now? We have to write down the first equation, then times with the derivative of the second equation. So you see that here second equation is the natural log function, so we have to follow the rule for the logarithm function. Okay, so it will be, okay, the here function of x is x, so the derivative of x is 1, then divided by the function which is x, then plus, okay, second function, and times with the derivative of the first function. So the first function is x square, the derivative of x square is 2x, so it will be 2x. So the at last we get x plus 2x ln x. Okay, in this slide we discuss how to find out the derivative of an exponential function. Suppose this is the exponential function where y is equal to e to the power u, and remember that u is a differentiable function of x. Then dy by dx, it will be equal to, first you have to write down this exponential function as it is, then you have to times it the derivative of u, which is du by dx. Let's do some exercise. Okay, so the first exercise is function of x is equal to e to the power 4x to the power 3. You have to find out the derivative of that function. So how to do this one? The derivative of that function, it will be equal to, okay, first you have to write down the exponential function as it is. It will be e to the power 4x to the power 3, then times with the derivative of 4x to the power 3, which is 12x square. So it will be equal to 12x square e to the power 4x to the power 3. So now let's begin with the second exercise, where s is equal to 3t e to the power 3t square plus 5t. So you have to find out the derivative of that function. Now you have to understand that here we have to follow actually mainly three rules. One is constant times function, another rule is the product rule, okay, and then the power rule, of course. So now you see that here the derivative of that function, it will be equal to, okay, 3 then times with the the first function, right, then times with the derivative of this function where it is an exponential function. So follow the exponential rule, e to the power 3t square plus 5t, okay, it will be as it is, then times with the derivative of 3t square plus 5t, which is 6t plus 5, then plus, okay, 3, okay, it is constant, then times with the that means the derivative of the first function, which is that it is 1, and then the second function e to the power 3t square plus 5t. So now after simplification, you will get 3 e to the power 3t square plus 5t times with 6t square plus 5t plus 1. So now next, okay, this one where the function is u is equal to w by 3 e to the power 3w. Now you have to find out the derivative of this function. Okay, now here in this case you see that it is a fraction. Of course you have to follow the quotient rule. Okay, so the derivative of that function, it will be equal to, first you write down, suppose here we assume that this is u and this is v. Okay, first write down v first, which is e to the power 3w times with u, the derivative of w, it is equal to 1, okay, then minus, okay, you have to write down the u, then times with the derivative of e to the power 3w, which is, you follow the the exponential rule where it will be e to the power 3w times with the derivative of 3w, which is 3, then divided by, okay, this one is the v square means e to the power 3w whole square. After simplify, you will get 1 minus 3w divided by e to the power 3w. Okay, so in this slide, in this video we discuss all the rules of the differentiation.